Okay, hello. Changed settings in OBS a little bit earlier today, and I had to change another setting to get it working again, but that is fine. Okay, I want to talk about hard drives today and kind of like why do we choose certain type of hard drives and why is it so important? Why are hard drives so important to uh, our computers? Because good quality hard drives, they really determine everything. But hard drives are really like one of the most important aspects of your computer. They're the long-term storage. They are the devices that are most likely to go bad, uh, and they're changed a lot over the years. They aren't exactly the same thing as what we used to have. Uh, we used to have those good old 2.5 by 4 inch long mechanical drives that have spinning discs in them. Now we are dealing with uh, chipsets, devices that have little chipped memory on them. Uh, so yeah, the hard drives are extremely important, and the quality and capability of your hard drive affects a lot of things. And some of those things we don't actually talk about a lot because most people don't quite know what they are. um, Good quality RAM, good quality hard drive that can transfer data at higher rates can make your computer download stuff quicker. Interesting. That's a little interesting fact, but yeah. Um, is my mic sensitivity low? Oh, interesting. Okay, let's turn that up just a little bit. Or am I just talking very quiet today? Here, I'll raise the volume up there too. Okay. So hard drives are probably one of the most important, not the most important, but one of the most important parts of our computer. Trying to open a new one here for us. This thing is so tightly packed in there. So this is a Cvent Rocket NVMe that I'm opening up here. And let's get a nice good picture of this little guy. This is a 1 terabyte solid state drive. It's part of their Rocket line. It is definitely one of the uh, faster read and writes than some of the older drives that are out there. This is a PCI 3.0 drive, not a PCI 4.0 drive. But the quality of your hard drive will make a drastic difference in what your computer can do. Because the more read and writes that it's capable of doing per second, the more data it can transfer around, and the less lag that could potentially be happening when you're doing things. Now, common things that this really matters in: um, Photoshop, 3D design, anything where you're going to be making a lot of read and writes. And that includes like high end IT stuff like virtualization. So, this little guy, that's 1 terabyte. Kind of take a look at the front and back of it. Nice and tiny. Nowadays, you can buy whole server clusters that come with little drives like this running your operating system. And this is where you want your operating system to run. You want your operating system to run on the fastest one possible. And then what you do with mechanical drives, which are still really important to your builds nowadays, you put mechanical drives on there for your long-term storage. And the videos, music, stuff like that that's going to be stuck around, pictures, games. You put all that onto the mechanical drives, and then you pull those information into your solid state drive when it's necessary, but you keep them on the mechanical drive when it's not. And these little drives operate so much quicker. And because I can put this directly onto the motherboard, because it has slots inside the motherboard, um, I'm eliminating the need for cables. So we'll start out with that one. There's no power cable connecting this. There is no SATA cable connecting it to the motherboard, so it doesn't need that to send data back and forth. It's directly connected to the motherboard on a PCI slot, so you're eliminating that extra time that it takes to go down the cable. You're eliminating the extra power that it draws by connecting to the power supply. And then because it's a solid state drive, it's going to store memory more efficiently. And you're going to have a lot better outcome for that in the long run. Today, everyone gets to see Ryan draw. uh, so, mechanical drives run off a disk, but that little NVMe stick has no moving parts. There's absolutely nothing moving on there. But this mechanical drive does. And we have we have to take that into consideration about things, because it has moving parts, which means it has more likely to break. Whenever you involve friction into anything, you have the higher chance of it to stop working. Um, and another thing with mechanical drives is that they have these little like platters, these metallic platters, and all you're doing is storing electronic, little magnetized spaces on there. And it writes in a circle. It writes in an ordered circle going all the way around the drive. Now you're probably thinking, okay, that makes sense, but think like that. Think of if information is stored like this, okay? And it's going to store to the next available spot. But if you delete a package, it's going to delete wherever it's at. Now imagine as you're doing things, okay, the black line was everything that was originally written, items got deleted. Now I start writing in again because it's going to use the next available set of data. And then all of a sudden, when I put the next file in there, it's not going in the same place. It's not going directly one after another. It's going to wherever the next in line empty spot is, and this is what we call fragmentation. And you'll hear us talk about defragging things. Um, it's because of this. It's because of what you're seeing here, um, and this happens every single time a mechanical drive is used. It fragments things. Now, Windows and Linux and Mac, they all have nice little programs in the background that defrag as they do things. Windows will defrag mechanical drives whenever the operating system is not being used. So anytime the operating system is not being used, it'll ramp up the CPU capabilities and it'll move all data back in line. So it'll move this red spot back out and rearrange things so that it's all one black line and one red line. Uh, but only as if it has space. If you shove so much data onto the disk that you're literally using like 90% of the disk, it will not work. It won't do this. won't be able to defrag. Other things with this disk, and because it's mechanical, it has a lifespan. Again, moving part, right? So very seldom is it actually one disk. You can have multiple platters in that disk, and each one of those ones is moving. Has a little arm bar that's coming in there, and that little arm bar is reading the magnetic information that's on it. Uh, if anything at all gets on there, a speck of dust, anything at all, and that little bar hits that, uh, it's going to cause damage because now it's going to scrape it across the platter, and that's going to cause issues. And that's we don't want that. We just don't want that. Uh, we have special features, special things that we can do where we can run like an unstuck feature, which will make this little bar run across there and try to remove the speck of dust uh, capabilities to kind of gain things back. But you're always going to lose something. You're always going to lose something with the hard drive. Eventually, most hard drives will die. Um, Realistically, you only have maybe 7 to 8 years, and that's about it. After 7 or 8 years, it's probably going to die. Uh, it's probably going to die. Solid state drives are a little bit different though. Solid state drives just act a little bit differently because we're doing things by electronical impulse. We have all these little caches that are on the drive, and again, it's going to store it wherever something's available. But because they're electronical impulses and not magnetic impulses, and there's no moving parts, the drive will read it quicker because there's no swing arm involved in this where uh, where it has to move that piece of metal back and forth across the disk to try to find anything. It already knows. It already knows where it is, and all it has to do is reach out to that sector and pull that piece of information. It doesn't have to spend the extra time of sending the arm over there and reading that magnetic impulse. So these are significantly quicker. Uh, and one of the cool things that we get out of doing stuff like this is taking these SSDs, and we can actually turn these into special types of RAM on some systems. Uh, they make special types of add-on cards. We're using SSD mechanics to act as secondary RAM for certain types of computers to be able to pull additional RAM. Now, before I kind of talked about like RAM having like, let's say, your home computer, you have a really nice one, you have 128 gigs of RAM sitting there. Uh, Imagine tossing a 1 terabyte solid state drive in there too that can read it. So yeah, we're just massively increasing it. And then you get to these little NVMEs. You get these little NVMEs with all these little tiny chips on them. And now, because it's not acting like either of those mechanical drives, which have to have a little cable connecting them and running outwards. Um, or that older school solid state drive that also has a cable that has to connect to a motherboard. I'm connecting this directly to a motherboard, so I don't have to deal with that. Don't have to deal with that. It's directly on the motherboard in a little slot. I have this little half circle hole that you connect directly to the motherboard. And we actually put thermal covers over top of these now. So I can put a little thermal cover over top of it to close down on top of it to pull the heat off of it. And it's going to decrease the temperature of that whole area. Why these are so important? Why is it so important to have a good quality drive? Reads and writes. How quickly can it read and write? Now, Intel has been running 3.0 for quite a while, and their next system is going to be moving to the 4.0 PCI. So you have, let's think about this. There's my motherboard. There's my CPU. There's my RAM. There's my NVMe. There's my graphics card. Okay. Now previously, if I was not running and I was just using regular solid state or mechanical drives, and I was connecting them off of here and running that little cable out there to those mechanical drives. Let's put a south bridge on there so we're keeping track of things. Okay. So the CPU decides, hey, I need to store something long term. Previously, it had to get all that information all the way to down south bridge and out the cable to the drive, and then back through the cable to the internals of the motherboard and back to the CPU and RAM to be able to hold that information and be able to pull it. That's quite a bit of distance. That's quite a bit of distance because you have to go down that cable, and I keep stressing that. Now imagine though, I didn't have to. And now I just have internal PCI ports that are going to Southbridge. So the CPU is like, hey, I need data. RAM's like, okay, yeah, I can get your data. Reaches down there to the Southbridge. Because I have no cables and it's directly connected, and it's reading at 6,000 reads and writes per second, I can load and access programs and applications quicker. If I'm pulling something from the internet now, because there is a spot on the cable, right, on the motherboard to attach, that gets connected out there to the World Wide Web, because I don't have to go down these. And because the PCIe is running so fast, my downloads start taking less time. My applications load quicker. My games run faster because all of a sudden we can rewrite the way the program accesses information, and we can start telling it, hey, you can store stuff on the CPU, or you can store stuff on the NVMe, request information there when you need to, and only bring things up to the RAM. It's basically you're shortening the amount of time to do anything, and this is all. This is about. The whole conversation we keep on having is how much time does it take to do anything, and yeah, a faster hard drive with more read and writes directly connected to the motherboard, running on higher PCI, which allows for quicker clock rates of data going back and forth between the various motherboard parts, getting to the CPU, which can run and read at even more CPU time, you just get quicker systems. That's all it is. You're just getting quicker and quicker systems. Because we're really getting to that max point with our CPUs. Yeah, we're adding more cores and more stuff like that. But adding that hard drive in there and increasing its capabilities will matter so much more. That's why it's very hard nowadays to find a brand new laptop being sold that doesn't come with an M2. You're very unlikely to go out there and find one on sale that's having a mechanical drive. And because we're putting those small, we have the capability of having smaller and smaller laptops. So this is a Razer Blade Stealth, and you can look nice and thin, right? You would not be able to have this type of thin computer, this nice lightweight computer, without NVMe's. And this really makes those computers work. That instant on functionality. You press the power, it turns on, and it's ready to use in a matter of seconds. That's why you have these type of drives. You're not going to get that on a mechanical. Now, is a mechanical or mechanicals dying? Oh gosh, no. The mechanical is just as important as it used to be. Now more than ever, because we can use it as long-term storage, and that is extremely important. Long-term storage. And you're going to find a lot of higher-end systems are going to have maybe 2, 3, 4 of these attached to it. The tiny ITX board that I showed off last week, that has one underneath it, and that's where this guy's going to go. This is going to go attached to the underside of it. My big desktop computer, its NVMe is sitting right underneath the graphics card. With these systems to have more utilization nowadays, we're going to put mechanical drives in them. We're going to put mechanical drives, and those drives are going to act as additional storage, and that's it. So why did I choose this one for this build? One, decently priced and fast. Remember, the purpose of this machine is going to be acting as a streaming device. So I will take some of the resources off of the main workstation, put it onto a streaming machine instead of the main computer. And now with a really fast hard drive, that means I will be able to record directly with 4K as it streams, and still allow the rest of the applications on the computer to do what it needs to do. So you could game at 4K. You could create high-end photos at 4K and have another computer that's capturing the visuals as you're doing it, which is closer to what real-world production is. Yeah. Hard drives are fun. These fluctuate in price a lot. Some years they're cheaper, some years they're not. What you're kind of looking for is that dollar per gig aspect, and really the appropriate amount should be right about $1 per gig. So less than $1 gig now. I guess it's like 25 cents. I have to take a look at that math, but a 1 terabyte drive should cost you between $100 and $150 for an NVMe. If I was going to buy a mechanical 1 terabyte, it should cost me less. If I were to go buy a standard SSD, that's a 2-inch one, that should cost me less. This will cost me more because of the components that are in it. Because of what it is made out of is going to make it more expensive. And as rare minerals on Earth become harder to find, harder to produce, and if they can't synthetically create it, if you can't do that, prices are going to rise. RAM prices will rise. Every couple of years, RAM prices go astronomical because um, the materials become harder and harder to find. And if we can't create it synthetically, we're going to get to a point in time where it's not feasible to create those other drives. Another reason why NVMe is so important because it is using less material, super tiny, using less. Okay, that's kind of it with hard drives. All I wanted to talk about today. They're really, really important, and don't skimp on them because without a good hard drive, without a good amount of read and write, then quite honestly, you're going to waste a lot of your capabilities of your computer. Yeah. All right, everybody. I think that'll be it for me tonight. Have a good night. Bye.